Hey, how you doing today? I'm gonna show you what differentiability is. So to explain differentiability, we should recall what continuity is. So remember that when we say there is a function that is continuous at x equals a, we're saying that basically the limit as x approaches a from the right side, that is from values bigger than a, greater than a, for the function f of x is equal to the function evaluated at that point a, and is also the same as the limit as x approaches a from values a smaller than a. Okay? Now this is the definition of continuity. Now there is a there's like a lot of resemblance between this definition of continuity and the definition of differentiability. Now since we're talking about differentiation, we're not gonna see like how the function actually moves or behaves when both limits are approaching a specific value, but rather how the function of the derivative of the function now is behaving when we're getting close to a specific point. So let me show you what I mean by that. So what if we had the following graph? We could have something like this. Now let's say we have something like this, and let's say for example that this is going to be a. Now if we wanted to find, for example, on the tangent lines getting very close to a, so for example let's say that we're on this point and the tangent line would be something like this approximately, and let's say we're also like on this point, okay, and you have a tangent line like this. Now I want you to think what would happen if you try to bring these 2 points very close to a. So like if you try to bring all those 2 points to a, what would happen with the lines, with the tangent lines? Well, basically if we say this is line A and line B, you could say that as these 2 points, so as you could say maybe there was some distance, so we could say this is h. So as h approaches 0, a is gonna be equal to b. Okay, I hope you can see what this means visually. If you bring those 2 points together, the tangent lines, which is basically the derivative evaluated at those x values in this region, they're gonna be the same line when they get to a. Okay, now this is the main idea behind differentiability. Now from this you can say that a differentiable function is going to be the limit, as we could say x approaches a from the right side, for the derivative of the function f of x. Note that we're using the apostrophe for f prime, okay? Now we're not simply using f of x, so we're saying f prime of x. This should be equal to the limit as x approaches a from the left side, and this should be the same for the function f prime basically. So this condition should be true if the function is differentiable at x equals a basically. This is differentiability. Just if you want to see it by the definition, this is it. Now we're not playing with the function but with its derivative, and if visually in terms of a graph, you basically have, imagine you have a curve and you have an a point and you have the points, or you could say the tangent lines that represent the derivative. And now what would happen if those 2 lines were getting closer and closer to each other, or these 2 points? Eventually the line A and the line B would be the same, as the distance between those 2 points we selected approaches 0, okay? So this is basically the definition. This right here is the definition of differentiability. And basically you say that a function is differentiable at x equals a if this condition is true, basically. On following videos, we're going to go over some functions that might be continuous but are not differentiable. That is an idea that actually exists in math. Some functions are continuous but you cannot differentiate them at some points, okay? And it's pretty cool. So, well, I hope you learned something today and see you in the following videos. Bye-bye.